Okay, we need to do a bit of work on methods of proof. It'll only take a lesson or two. But there is a new method of proof that I don't think you've seen before. Some of you will have done, and that's proof by contradiction. And the way this proof works is you assume the opposite and show that it can't work, and you get a contradiction, and so therefore the original statement must be true. So what I'll do is I'll go over two proofs so you can get a feel for what's happening. One of them is proving that root 2 is irrational. The other is proving there's infinitely many primes. These two proofs are examinable, so please copy them down, make sure you understand them. I don't know what examinable means, by the way, at the moment, but just be aware that you're meant to know these proofs. So, yeah, any problems with that, let me know. So rather than proving that root 2 is irrational, we suppose that root 2 is rational. And we show that this is impossible. And because root 2 is either got to be rational or irrational, if it can't be rational, it must be irrational. It's got to be one or the other. And that's quite key to a contradiction proof as well. So if root 2 is rational, we can write root 2 as a over b, where a over b are both integers. And this is a fraction that's been cancelled down to its simplest form. Squaring both sides gives that 2 is equal to a squared over b squared. Multiplying by b squared, 2b squared is equal to a squared. 2b squared, so this is a multiple of 2, and so 2b squared is even. Therefore, a squared is even. And so a is even. So even squared gives you even, and vice versa. If a is even, then a equals 2n for some n where n is an integer. So it must be a multiple of 2. And then I'm going to substitute 2n into this equation here. So substituting into 1, this gives that 2b squared, a is 2n, is equal to 2n squared. And so 2b squared is 4n squared. Dividing by 2, b squared is equal to 2n squared. This is a multiple of 2, and so we've shown now that b squared is even, and if b squared is even, then b has to be even. So just following through this argument. And so b will equal 2m, where m is an integer. But now, a and b both have a common factor of 2. And so if you think about writing them as a fraction, you'd be able to divide top and bottom by 2. And so a over b is not in simplest form. And so that is giving you a contradiction. So it's impossible to write root 2 as a fraction in simplest form. Therefore, root 2 can't be rational. And if it can't be rational, it must be irrational. And that's how a proof by contradiction works. So you've basically shown that the opposite is impossible. And so the original statement must be true. You'll get a hang of that as we go along. So this is a contradiction. Therefore, root 2 can't be rational. So it's quite a lot of writing. I'm trying to write quickly. Can't be rational, so must be irrational. And proof by contradiction is actually a really powerful method of proof. I remember using it so much in my degree. So it's really key to a lot of proofs in maths.